In Lesson 6, we're going to work on modeling and word problems with our exponential functions. So the first one says an oil spill of 250 square miles is being cleaned up at a rate of 15% per day. Determine the number of square miles of oil remaining after 4 days. So if we're looking at how much is remaining after 4 days, that is going to be our decay or our decreasing function. So in that case, we're going to be 1 minus our percent as a decimal. So the first thing we're going to do is look at our percent and convert that to a decimal. So you can either divide it by 100 or move the decimal place 2 spots to the left, and it gives you 0.15. So our formula is going to be y equals, we're starting with 250. We're going to be 1 minus 0.15 to the t. So there's our equation. Now, if we're looking to figure out after 4 days, you could do the subtraction to get 0.85 or not. It's up to you. We're going to plug in a 4 for our exponent since they want 4 days. And when we plug that into our calculator, we get that there is 130.5, and the decimal goes on, but we'll stop right there. Square miles of oil still remaining after 4 days. In our second one, Jackie deposited $5,000 into an account at Key Bank, earning 4.2% interest compounded annually. She made no deposits or withdrawals. Write an equation that can be used to find B, her account balance after T years. So when they say earning, we're going to be increasing. Therefore, we are 1 plus our percent. So we got to be careful here as we convert 4.2%. It's 0.042. So our equation is going to be B equals, she starts with $5,000. We're going to be 1 plus 0.042, and then to the t. So you could also write it like this if you would like, where you just combine the two together and you get 1.042 in your parentheses. It's up to you. Determine the amount of money in Jackie's account after 7 years. So in that case, we're going to use that same formula, but instead of t, we're going to plug in a 7, throw that into our calculator, and we get $6,668. Now there's a big long decimal, and it ends in 743. So remember, money can only have 2 decimal places, so 743 would involve that 3 just disappearing, and the 4 is going to stay the same. It's not going to round up. And the last one, the amount A in grams of a radioactive material that is decaying, so we know it's decreasing, can be modeled by A of D equals 450 times 0.88 to the D, where D is the number of days since it started to decay. Find A of 14 and interpret its meaning. So if we're going to find A of 14, that means in place of D, because the 14 replaced our D, we are going to plug in a 14. So 450 times 0.88 to the 14 gives us 75.157, so we'll go 0.16 for rounding purposes. Now it also says to interpret what that means in the context of the problem. Well, the 14 went in for the days. So after 14 days, the amount, that's the 75.16. So 75.16, and in this case, it's going to be in grams. So 75.16 grams of the material remain. Determine if this function represents exponential growth or exponential decay. This is going to be decay, and the reason is, if we look at our equation, you always want to focus your attention on what is in the parenthesis. So when you do that, you're going to look to see if it's greater than 1. So since 0.88 is is less than 1, this is decay. Now, you also should have known it was decay because after 14 days, there was less of the material left than there was in the beginning. But you really want to look at that number inside of your parentheses. Now, I know the question doesn't ask this, but I want to talk about it real quick. The 0.88 represents 88% remaining. It does not represent the rate of decay. In order to figure that out, what did you subtract from 1 to get 0.88? And the answer to that question is 0.12. So 0.12, which is really 12%, is your rate of decay. And that's something that we're going to talk about more in the next coming lessons.